Today we're going to take a look at exponential growth and decay. Two different things. Growth means getting larger, decay means getting smaller and dying. We have two formulas to get there. Both these formulas, they look very, very similar to each other with the exception of one little thing. One's got a plus, one's got a minus, but they're both handled in the same way. Now we need to understand what all these variables mean first so we can eventually fill them in. Y is going to be our ending point. A is going to be our starting position. R is rate, or the percent that we're dealing with. T is, shocker, time. And together, that parenthesis, we call our growth factor. Okay, now can I use that information and bring it to our decay problem? Y is ending, A is starting, R is rate, T is time, and this guy, just the parenthesis, we call our decay factor. Now, we understand at least what letter is what variable is what. Now let's put things together and figure out which one of these we're using. So viruses, and when we're dealing with growth and decay, it's usually going to be word problems. So got to deal with that. A virus that starts in one computer spreads at a rate of 10% more computers every minute. How many computers are affected after 30 minutes, 45 minutes, 60 minutes? There's three questions we're asking here. Now we got to break this down. So we got a computer virus that keeps getting more and more and more and more and more. If we keep growing, we're using exponential growth here. So here's our problem that we're looking for. Spreads at a rate of 10%. That's my R here. What are we starting with? Our starting point, we start at one computer. Thankfully, it tells us where we're starting. And we're looking for 30 minutes. After 30 minutes, what are we left with? So let's take these three numbers, plop them into that formula. Y equals A, what are we starting with? One computer. 1 plus, I could say 10%, and then my time after 30 minutes. Now, I got a problem here. I don't like putting this as 10%. Instead, I want to write this as a decimal. So I'm going to take that decimal that's at the very end, move it over twice, and we're going to rewrite this as 0.10 or just 0.1. Now, order of operations. 1 plus that gives us 1.1. Raise that to the 30th power, and we'll end up with 17.48. I'm going to take this multiplied by 1, but you're still there. So after 30 minutes, 17 computers are infected. We got to do this again, but this time we're going to use 45 minutes. So again, 1 plus 0.1 gives us 1.1, raise that to the 45th power, and we're left with 72.89. Wow. We can say 73 computers because we're just about there, rounding. And then lastly, do this again with 60 minutes. 1.1 raised to the 60th power is going to give us 304 and 48. 304 computers. So now we can only use these problems when our time, we're moving at a consistent rate each time. Otherwise, we got to dip into a different formula. But exponential growth and decay, sometimes you might be asked more than one question at times. Let's make sure we answer all of them. And that is exponential growth and decay.